Welcome back. In my last video, I discussed the essentials of case preparation, which involves merely inspection of the cases for correct functioning, make sure that they're to dimension, and make sure that they suffer no defects, and also to check them for case length and trim where necessary, and how to chamfer and deburr the cases. Those are the essential steps. And those will generally, anybody who performs those steps and loads conscientiously and according to the standard guidelines of loading and develops his loads can expect to have very, very good accuracy from a firearm. Now, there is another level of accuracy that a person can seek. And let me first of all see if I can open up a little bit of an understanding about where we're getting here. Typical factory guns these days are capable of minute of angle accuracy. Now, just to clarify what that means, minute of angle is 1 inch per 100 yards. In other words, that bullets will fall center to center at least 1 inch per 100 yards. So that would be 2 inches at 200 yards, 3 inches at 300 yards, and so forth. So a 1,000-yard gun, a minute of angle accuracy would be a gun that can shoot a 10-inch group, center to center, or to the same leading edges of the bullet holes, which is the easiest way to measure. But now, when those specifications are given in the warranty, so if a firearms manufacturer warrants his gun to be capable of MOA accuracy, with factory ammunition, that tells you something very important right there. That tells you that standard factory ammunition, which is loaded with brass, which is available to any hand loader from their factory, whether it be Winchester, Remington, Seiko, Lapua, Hornady, Nosler, no matter who makes that particular ammo, that you should be able to expect MOA from that gun, unless they specify a particular type of ammo. But that means that the concentricity of those cases and the weight of those cases may be somewhat varied, the same as you would buy in a lot of brass in a bag. So if I'm shooting standard factory cases that have been in no other way segregated or treated for accuracy, I can expect that gun, if it so specifies, I can expect that gun to shoot MOA with the factory ammunition that they prescribe. Now, that's pretty good accuracy in anybody's book. And I really don't expect to see any degrading of accuracy from that practical standpoint to be of any serious concern to the average hunter. In other words, the average hunter can certainly go afield with a 1.5 minute of angle accuracy gun, and he can certainly stand up against any deer at any reasonable hunting range. So MOA is a pretty strict level of accuracy. Now, a little bit higher accuracy can be achieved with a little bit of extra attention. The very first level of attention that a person can give is with regard to segregating according to weight. In other words, brass that all weighs the same and is dimensionally sized the same on the outside will have exactly the same interior case capacity. The interior case capacity basically is the combustion chamber for the powder that you put in it, and when that chamber dimension changes because one case has got more brass, substantially more brass than another case, then that lessens the available combustion chamber area. Now, having said that, that sounds a little bit of a caution, but it's not. In my personal experience, there was a period of time that I went through back in the 70s where I remember sitting at the kitchen table and with my beam scale measuring out all my brass and segregating it into Tupperware containers, and I had them marked for how much how much each weighed, and I had them, you know, there'd be 12 in this pile, there'd be 8 in this pile, there'd be 1 in this pile, 1 in this pile, 1 in this pile. And, you know, after a while they got mixed up again at the range, and I said, you know, I'm wondering what's going on here. Then I started doing some accuracy testing with regard to shooting within those segregated batches and checking them against each other, and I found that there was really no substantial difference. And I'm talking about some of those cases being grossly varied in weight. So I didn't find that to be a big deal. And then later on, I discovered that the reason why it's not a big deal is because, for the most part, I was using extruded powders, and extruded single base powders tend to be pretty uniform across the board. In other words, as conditions change, or even as you increase load capacity in a particular case, they don't tend to jump around on the paper. And I discussed that in a different video. There tends to be greater uniformity with extruded powders. Ball powders can show a little bit more erratic tendency with regard to the amount of charge weight. So in other words, when you nail a specific accuracy load with a ball powder, you generally have to stay pretty close to that charge weight. And changes in temperature can affect basically the amount of combustion, the heat that cartridge generates that day, and that can affect ball powder more drastically than it will extruded powders. And now Hodgdon has powders which they call the extreme powders, which give you they claim a little bit extra control over those variations in temperature. But I've always found that extruded powders were always more uniform. So that kind of levels out the amount of discrepancy. Now, certainly, you know, if you are a match target shooter, then I strongly suggest that your cases be uniform in weight. But I will say this: if you're a match shooter and you want to have your cases segregated by weight, forget the Tupperware thing. Start out with just, you need to invest in good cases that don't have that issue. These cases, for instance, are all Lapua cases, and I've had similar results with Nosler cases and things like that, and I'm not recommending any particular brand, but these cases don't vary by as much as a tenth of a grain in weight. They really, these are Lapua 22250 cases, and when I first got them, this particular lot, I weighed them all out, and the greatest variation I found was 0.3 of a grain from top to bottom. That's an extraordinarily small variation in weight. That's where the target shooter really should, if you're really interested in that level of high accuracy and you're interested in segregating your cases, segregate them from the get-go from a manufacturer that develops his brass at that level. And really, it's almost fool's folly to try to segregate inexpensive brass, which comes out of the press varying as much as 1.5 grains or 2 grains per case. It's very difficult to start segregating those, because you're gonna end up with 10 batches of ammo, and for what it's worth, it's hard to figure out exactly what it is that you do with it at that point. This batch has to be loaded with a different load than this brass. It gets nonsensical. So whether they're segregated or not, at that point, with that type of brass, I just simply let it go. It's not a big deal, okay? Now, like I say, if it is a big deal and you want to make sure that you have a very, very uniform brass, just invest in it. That's the easiest way to do it, and then you don't have to worry about it. Now, there is another issue which is, I think, materially effective in improving the group size of any given rifle. Now, I'm speaking now of factory rifles, and then I'll talk about the bench rest rifle and how it has particularly unique traits that is different, vastly different from a factory rifle with regard to its chamber. Factory rifles have got a chamber which is extremely loose in all reality. In other words, it has to be able to accept any brand of cartridge that is made, and it has to be able to go into any rifle chamber that is made. They both have to be cross related. There can be no problems or distinctions with regard to the brand of gun or the brand of ammo. All ammo has to fit in all guns, and vice versa. So that's the criteria that they have established in the industry, whether it's for military or civilian use. So that being said, there's quite a lot of slop in a case, in a cartridge case when it goes into your chamber. Now, in another video, I have explained that when a firing pin comes forward on the back of the primer and drives that case forward, it's driving it forward in a somewhat loose chamber. When it does so, the tapered neck of that case rides up as if it was riding up a ramp. Just imagine just tires going up a ramp in a garage. That conical shoulder rides up, and it seats itself into the forward section of the chamber. At that point, there is a gap between the bolt face and the cartridge case, and that gap is known as the headspace. That's where the term derives its name, is the headspace between the bolt face and the cartridge case head. Now, the measurement is not taken from that point. The measurement is there are three different types of case headspace measurements. With bottleneck cases, is typically from the datum line of the center of the shoulder back to the rear of the case head, or in the case of a belted case, it's taken from the forward section of the belt, or in the case of a rim, it's taken from the forward edge of the rim. So there's a difference in the way that the headspace is measured, but with a rimless case, such as a 22-250 or a 30-06, 270, 243, any of those cases that are called rimless, in other words, the rim is no bigger than the case body, that case slides forward and comes to rest at the junction of the shoulder. And there is that gap that I speak of, where there's a little bit of slop in the chamber, and that gap at that moment when the cartridge is fired suddenly is filled up, because the primer is the first thing that happens is the primer backs out, and because it's the lightest and it's the least resisting, that backs out from the combustion of the powder inside. The primer backs out, and then shortly afterwards the case follows it and stretches. The stretching occurs basically toward the bottom third of the case, and that stretches back to fit into the chamber. So everything fits snugly at that instant of firing, and there is no gap anywhere. The tremendous pressure that's created fills the entire chamber. When that happens, the very that shoulder, the forward shoulder of the case, as it's driven forward into the chamber. Remember, both mate precisely at that moment, and the effect of firing forces everything to conform to the chamber dimensions. At that particular point, wherever that bullet happens to reside is where it's taking off from. If you have a case neck that is thicker on one side than on the other, in other words, if you can imagine the circumference of that case neck, the brass case neck inside the case neck area of the chamber, if you can imagine that it's thicker on one side than the other, it offsets the center line of the bullet. So the axis of the bullet now is not actually looking down the center of the axis of the barrel. We're talking about a very, very small offset in most cases. We're talking about an offset which can be little to nothing. It can be very, very slight. With high-grade cases such as these here that are made to very, very high standards, it can be less than 1/4 of a thousandth of an inch from one side to the other. With some cases, it can be much, much more. It can be several times more than that, and that offset will mean that the bullet's axis is not conforming to the center line of the bore's axis. So that means that when the bullet exits the barrel, it has been driven into the lands on one side on more than the other, and the bullet has been forced to conform to that position that it started out with, and that can cause all kinds of eccentric behavior on the part of the bullet. So it's basically flying a little bit off center. And if you've ever driven on a tire that is unbalanced, you can physically feel that thump, thump, thump at 55 or 60 miles an hour where the irregularity occurs on that tire, and then you have to put a lead weight on it to balance it out. Well, what we do to balance out the concentricity of a bullet in flight is to center that bullet's axis to be in conformance with the barrel's axis. The way that's done is with some form of case neck turner. Now this is a bench-mounted Forster brand turner. I like this because it gives me good leverage. It speeds things up, and I don't get crampy hands from turning one of these gizmos in the hand. But a lot of bench rest shooters like to use the one that they can sit at their TV and watch and do all their cases. This is a one-time deal only. You only do this one time to any case. You cannot keep recentering there's no need to keep recentering your brass case necks. Once they're centered, they're centered. It's typically something that you do when you first acquire brand new cases, and they're all fresh and clean, and there's no dirt on the inside of the case mouth that would cause problems with it turning on the pilot. The pilot is the centering device which controls the thickness of the brass at any given point around it as the cutter goes around it. So basically it maintains a standard. Now, you can certainly do it to older brass, but you just simply take a case neck brush with a little bit of Lee lubricant on the brush, just a tiny bit. That's all it's necessary. Just put some on your fingers, wipe it on the brush, and go down your loading block and basically clean out the necks just with one pass. And that amount of lubrication will adequately clean them up so that they'll glide on that pilot. The cases have to be sized so that the pilot is in a tight case neck. The pilot is sized for that purpose. And the pilot is a longer than standard pilot. It's got parallel sides that run usually about a ½ inch long or more, so that it completely supports the case mouth from the front of the mouth all the way back to the shoulder. Now, the amount of brass that is removed, I'm not going to go into demonstrating the Forster because there are so many different brands of these devices out there. You can get different brands, and they're all going to do essentially the same thing. You follow the manufacturer's directions. It's very, very simple. The cutter is set so that it approaches the brass very slightly, and they're threaded, and that thread pitch will quickly advance that cutter. You don't turn a turn at a time. You don't even turn a half a turn at a time. You only turn think of a clock. You only turn from 12 o'clock to 1 o'clock at a time. That's all you do. In fact, it can be even less than that when you're approaching the final cutting amount. Never, if you're using cases for the purpose of sporting rifles, for factory rifles, never ever cut more than the slimmest amount that's on the case. You don't need to have a tubing micrometer, what's sometimes called a ball micrometer. This is all done strictly because it's irrelevant how thick the brass is, and I'm going to get into that when we get into the bench rest game. When you're talking about developing concentricity, the only issue that you're concerned about is making sure you remove the high spot, the high side. There will generally be a high side and a low side, the thinner side. The thinner side is the base. That never never cut into the thinner side because you're going to be weakening your case. You have to have good case neck tension, and you don't want to blow the neck off. That's a real serious issue. You don't want to cut into the case greater any more than the thinnest dimension, the thinnest section around that circumference. So the best thing to do is to basically leave that area right there. Maybe it's only an eighth of a way around. Leave it uncut. That will give you that base. In other words, you've cut 7/8 of the case dimension off, and you leave 1/8 as a proof that you didn't cut into that thinner portion. You don't want to cut into that thinner portion, and you never, under any circumstances, want to allow your cutter to ride into the shoulder area, because if you ride into the shoulder area, you can actually blow out that neck, and that can cause a bore obstruction when you fire your next round, and you have serious problems. So never allow your cutter to cut into the shoulder of the case. Once you've established concentricity, once that bullet is now centered down the board, you've accomplished everything there is to accomplish with regard to your rifle. As I say, factory rifles are made with factory loose chambers so that all ammunition will chamber. They sit low in the chamber waiting to be fired, or in whatever position the rifle is held. They sit in that position in the lowest portion of the chamber, and upon firing they ride up on that shoulder and center themselves, and when they go off, basically that's the position of the bullet. So they're self-centering. In other words, the two cones that are being centered against one another. So once you've established good case neck concentricity, the bullet will be positioned down the middle. Now we're going to switch gears and go to what occurs with the bench rest chamber. We're talking about chambers which are custom sized with custom chamber dimensions and using custom neck bushings for custom dies. We're talking about people now who are using extremely precise measurements, using tubing micrometers to measure the thickness of the neck wall. Now, we can go off into a really, really big area of discussion here, and I'm not going to do that. How much there has to always be enough release. There has to be a dimension of release clearance in the chamber of the rifle so that the bullet can slide out of the case neck on firing. It can't be absolutely tight. In other words, if that were the case, your gun would basically have an obstructed chamber, and the bullet would be resisted from firing. You can't do that. The pressures would soar. There has to be a release dimension. That release dimension has been discussed like a dead horse being whipped. Everybody has their own preferences. There can be that release clearance can be as much as 1/2 thousandth all the way around, which means 1/1000th of an inch, 0.001 behind the decimal point. Some people bring it to a smaller dimension than that. These are all fundamental areas of discussion around campfires where bench rest shooters sit. I'm not going to discuss that, but what that involves is simply the recognition that a particular chamber dimension with regard to the bullet dimension has a neck wall thickness which will accommodate a certain release dimension. Everything is mathematically calculated. You start with your bullet diameter, 0.224, you add your case wall thickness on one side, which is so much, and then you have to have a 1/1000th or a 1/1000th and a half or a 1/2 of a 1,000th or whatever clearance that the shooter deems as necessary for his rifle. He sets it up that way, and that's how he orders his case sizing bushings, his neck sizing bushings, and that's how he orders his chamber. And everything is conforming to that, knowing that bullet dimensions have a particular standard. So that's what occurs in that particular game. There is there's no particular need for anybody who's shooting factory grade rifles to even concern themselves with tubing micrometers, because you basically are only interested in centering the bullet. And once you've carved off the high side of that cartridge case, you've accomplished your goal. You don't want to be carving off too much, because your chamber is already over dimensioned. It's already bigger than any bench rest chamber would be to fit into that specification tolerance which is given in the industry, so that all ammo fits. So that's all that I can possibly offer on that subject. So don't, if you're interested in bench rest shooting and you want to get into formal bench rest shooting, you can shoot formal bench rest matches in what's called the factory class or hunter class, where you're shooting out of the box guns, and in those situations you're competing against people beside you who are shooting the same type of rifles. In other words, out of the box Remingtons or Winchesters or Seikos or whatever they are. The only requirement is that they be unchanged from factory specifications. No special triggers or anything like that. So in that situation, you're shooting a factory chamber. Those people will generally make sure that their ammo is concentric, so that the cases all position the bullets at the middle of the barrel. So this leads us to another area of discussion, which is the practice of neck sizing only versus full-length case sizing. Well, anytime a gun is going to be taken afield for the purpose of big game hunting, always, with all capital letters, always full-length resize. Prudence indicates that a person who's going after large game is interested in shooting at fairly large regions of a thorax that don't correspond to MOA. That's a different type of usage. These are game animals which are corresponding to your own physical inaccuracies in the field, judgments in distance, and all those things, which have nothing whatsoever to do with whatever gain that you might have that comes down to a quarter or a half of MOA. Has nothing to do with it. So always, under all circumstances, go for the gold when you're going after deer with fully resized cases that have no chance whatsoever in failing to feed. You don't want to have a situation where your bolt won't close in a hurry when you're trying to chamber around in the field. You want to have it drop in nice and slick. So everything is function, practical, practical, practical. Now, if you're the varmint shooter, or if you're the bench rest shooter, and bench rest shooting followed the varmint hunter. It was varmint hunters that invented bench rest shooting. The guys that wanted to shoot at woodchucks 500 yards away needed to shrink their groups from what they were getting out of factory ammo and factory guns. They wanted to shrink their groups and get to the point where they could shoot at woodchucks at 500 yards with their factory guns. This is where bench rest started, and then it started developing into more sophisticated classes that we know today. But the first bench rest shooters were all using, like Remington 721s and Winchester Model 70s and things like that. And those guns performed remarkably well. They down to the point where most of those shooters, even back in the 50s, were capable of getting less than 3/8 of an inch groups with field grade factory guns. It's the bench rest shooter who has been able to get it down to the point where we're sub quarter of an inch and basically drilling 10 shots in a virtually the same large hole. So that's a different sort of thing altogether. Cases that are fully resized. Remember what I said. When the case is fully resized, there's that gap, that headspace between the bolt face and the rear of the case head. When it first is driven forward by the firing pin, and then the case stretches back to conform to the chamber. That repeated stretching is what induces the lengthening of the case. The brass does, to some degree, actually flow forward like molasses, and the softer regions of the brass will actually flow into the case. But most of that most of that growth occurs from that repeated stretching of the case and then the resizing of the case, which it squeezes it like a soft tube. It squeezes it and forces that brass forward into the sizing die. So that repeated process, forcing it forward into the chamber of the rifle during firing, and the forcing of it over the expander ball, all these things acts upon that brass to continually stretch it and lengthen it. Whenever you take brass, whenever you're trimming it and you're taking brass off the case neck, that brass came from the body of the case someplace. You're taking material off of that case and it's growing, and something is thinning every time you take brass off of that case neck. And that's where you have to be a little bit considerate to your brass. And if you're shooting target matches where function is not an issue, where you don't have to worry about cramping the bolt home on a tight case and all those things, when it's strictly you and accuracy and the target, that's where it pays off to do simply case neck resizing. The case neck resizing actually accomplishes two things. First of all, is that preservation of the case that I've spoken of, because by not having the case constantly being stretched back against that headspace gap and growing in that direction, then you now reduce it to the amount of case stretch, which is the flowing of the brass forward from basically inside the case during firing. In other words, like you're rolling out pie dough. There is a certain amount of flowing of that brass forward as it goes out, but you reduce it to that amount. And certain cases are notorious for being more wasteful in that regard. The 22-250, for instance, has got a fairly good degree of taper, and cases which have a lot of taper tend to flow more than cases which have a fairly straight wall. In other words, 223 cases and 222 cases have got a fairly straight taper, so there's less flowage of that brass forward. But even with cases like these, now I only neck size these cases when I'm shooting, because I'm not interested in whether the bolt drops home. The bolt, as a matter of fact, I have to press it down, because those cases fit into the chamber very tightly once they're resized. Those are Lapor cases, and these are all neck turned for concentricity. The amount of brass I had to take off of these is hardly anything. I mean, it hardly even scuffs it, and it wants to scuff it all the way around, because there's no high side to be concerned with. So that's what happens with that. The preservation of the case then is something that case neck sizing alone will accomplish. It also accomplishes some degree of conformity with the chamber. In other words, the brass becomes a clone of the chamber. If you're going to use brass in the same rifle all the time, then you can use fire-formed cases which are neck-sized only in that chamber. You can't do that if you're going to use ammo in different rifles. For instance, if you have two 30-06s and you neck size to your Model 70, but don't expect to be able to fire that in your Model 700. It's not going to work that way. Even if you got two guns of the same manufacturer, the slight differences in head spacing, when the guy who was at the factory head spaced those rifles, those very slight differences will mean that one of those rifles will accept that case and the other simply won't. It'll go in there and it'll feel like you have a steel billet that you just tried to push a bolt against. It's not going to fit. And that's standard. That's standard for the course. You never, under any circumstances, neck size only when you're cross chambering from one rifle to another. If you're going to be using it only in that chamber and you fire form your cases to that particular chamber and you neck size only in that chamber, you can expect a slight degree of accuracy improvement. And when I say slight, I'm talking about very slight. We're going back to that MOA stuff that, you know, the factory rifles guarantee with factory ammo. That stuff is that's not fire formed to anybody's chamber. It's not neck turned for concentricity or anything, and yet they're getting MOA, and they're guaranteeing MOA. So you have to understand it and break it down from that level. If you're getting MOA with basically fodder that is sloppy in anybody's chamber and has no neck turned cases, they're just operating off of factory standard cases that have concentricity issues and everything else. If they're getting MOA with that, that's the base from which you have to establish your train of thought. In other words, what is it that you're trying to achieve after that? If you're trying to make your gun into a half MOA gun so that you can get half-inch groups like I get out of this 22-250, then you want to do your case neck turning and you want to do your case neck sizing only. And that'll give you your peak accuracy for that particular factory rifle. It's not a custom chamber. Nothing's custom. It's just a factory model 700. Now, what kind of neck sizing is good? Well, virtually any kind of neck sizing can be done with just a standard factory die, a regular factory die. All you really need to do is to do what's called a minimum resizing of the brass. In other words, don't run the case all the way home. What I did for many years was I simply took empty cases and I placed them into a chamber and I closed the bolt, and I know I got a feel for a tight bolt because it's just been fired out of that gun. So I put it in my resizing die. I run it in with a little bit of lubrication because you're still going to end up with a stuck die. Always lubricate the case body, never ever the neck, except perhaps on the inside slightly. Run it in and keep advancing the die until the bolt just barely closes, easier than it used to close. That's the point where you have completed a neck sizing operation and you have closed up your head space where everything is still tight. You can accomplish it in that way. What can occur, however, with using a standard die is that you develop a second bottleneck. In other words, there's a barely perceptible degree of thickening of the shoulder, I should say the thickening of the neck down at the junction of the shoulder. So in other words, if you looked at it with a magnifying glass, you'd have the larger shoulder, then you have a secondary shoulder. That occurs when you're using a full-length sizing die to neck size your cases only, because you're only running that neck down. You're only running that neck down to a certain point on the neck, and what you're doing is you're leaving a little bit of that expanded neck available so that it fits into the chamber, and that's what that's accomplishing. And that fills up your head space to the rear, and that's what gives you that nice tight bolt closure. The better way to do it, however, is with a neck sizing die, a dedicated neck sizing die. Most dedicated neck sizing dies simply have an oversized chamber body inside the die, and the only part of the die that contacts the case is the neck itself. Everything else is rather loose. In other words, you're just basically sliding the die down over the neck. They don't usually require, you check with the manufacturer, but they don't usually require lubrication, and it gives you freedom from having to lubricate your cases, and you can just simply run them into the die. What I prefer, however, is Lee's system, which is based on sizing around a mandrel, and it closes. There's a collet which encloses and surrounds the case neck and squeezes it around a mandrel. A mandrel being basically a steel rod, the dimension of the bullet minus a thousandth, and it closes it around that mandrel tightly, and it gives a bullet a 1,000th bullet snugness, which is exactly what you want to have, and that gives you proper neck tension. That's a system which it involves a collet inside. If you've ever seen handlebars the way they're attached to a bicycle, there's a collet in there that grabs the handlebars. It's exactly the same sort of thing. It's based on the same principle where as you drive the die up against the top of its stroke, the collet squeezes in. It's got fingers, 4 fingers, and they squeeze in on the case and enclose around the case down onto that mandrel. I prefer that over the ones that slide down because it gives you less manipulation of the brass. In other words, you're not milking that brass down as if you're milking a cow. You're not drawing the brass down, which changes its length and rolls it out like pie dough. It's basically just closing around the case and reforms it around it tightly. Now, in my next video, I'm going to get into what this does to cases. The process of firing and resizing causes what's called hardening of the case neck area and hardening of the brass. When brass is made, it's made really with 3 levels of hardness. During the cup and draw process, where they take a sheet of thick brass, which is punched out into coins. They basically punch it out into round circles, and then through progressive punching over mandrels is drawn. It is first formed into a small cup, and then is drawn and drawn and drawn repeatedly, and then finally stamped with the rim and all these dimensions that form it. Then it has to go through, that all hardens the brass like crazy. That repeated hammering of the brass and drawing of the brass hardens it. There's no softness that would allow the brass to conform to the chamber. It would be very, very brittle. The cases are annealed at the neck. In other words, the annealing of brass means that it's softened. And that softening of the brass allows it to have that nice closure around the bullet, nice firm grasp. It makes it elastic and very, very supple so that it can conform to the chamber, which is essential to seal gases off. That's why we have the ability to fire cases which have tremendously high pressures, because the front of this case acts as a gasket and seals that chamber tightly. The more pressure there is, the tighter that seal becomes, and it prevents gases from flowing back along the sides of the chamber. That was the greatest invention, was to have metallic cases that finally solved the problem of breech gas blowback. So now we have a problem where repeated firing and resizing again hardens that brass and makes it brittle. So later on I'm going to talk about annealing of it to return it back to its original soft state at the neck. So those things will be discussed when I talk about case annealing. You don't need to worry about annealing for at least several firings of any particular rifle case, and this is where a little bit of common sense takes place. In other words, if you keep your pressures down off the ceiling, you'll have greater case life than the person who constantly pushes the pressures right up to the very limit. That's it. Thank you for watching. Don't forget to subscribe. God bless.